Now we're going to take a look at two kinds of lines, parallel and perpendicular lines, and the slopes of those. So here goes another one of my hand-drawn graphs. Parallel lines are lines which have the same slant and inclination. Perpendicular lines have completely opposite slants and inclinations. They intersect, by the way, at right angles. You can tell pretty much visually here that these have the same rise and run, vertical change, horizontal change. If you have two lines that are parallel, the slope of one of the lines is identical to the slope of the other line. This is what happens when the lines are parallel. When the lines are perpendicular, you can see that one would be a falling line and one would be a rising line. That means one will be positive and one will be negative, but there's more. Not only will that happen, but they will be reciprocals of each other. Now that's written as M1 is the opposite reciprocal of M2. I'm going to just put in parentheses opposite reciprocal. They have to have those two characteristics, and if that happens, the two lines are perpendicular. Now let me give you just a quick example. If I had a line that was y equals 2/3 x plus 7 and another line that was y equals 2/3 x minus 4, take a look at the slopes of those two lines. Those two lines are parallel because their slopes are the same. An example of two lines that are perpendicular, if y equals 2/3 x, say plus 7, and y equals negative 3/2 x minus 8, look at those two slopes. They are reciprocals of each other, 2/3, 3/2. One is positive and one is negative. That's an example of what slopes look like when they are belonging to perpendicular lines. So let's see what we're going to be asked to do. It says determine whether the pair of lines are parallel, perpendicular, or neither one. So I have, this is nice, they're given to me as y equals 7/4 x plus 5 and y equals negative 7/4 x. Well, I have the slope, I have the slope. They are not identical, which means they are not parallel. But although they're opposites, they are not reciprocals of each other. So they are not perpendicular. My choice must be that they are neither one of those. So you don't have to be just parallel or perpendicular. It could be that you're neither. Let's look at number 2. Now these equations are not both in the right format. One of them is x minus 7y is equal to negative 8. Well, I need it solved for y. So subtract x from both sides. Negative 7y is equal to negative x minus 8. Divide by negative 7. Y is equal to, because that divides out. This is an implied negative 1 over negative 7. Negative over negative is positive 1/7 x. Negative divided by negative is positive 8/7. All right, here's the slope of the first line. Second line, y is equal to 7x minus 7. Well, that's already in the right format. There's its slope. Those are reciprocals, but they're not opposites. So they are not parallel because they're not the same. They are not perpendicular because they're not opposites. We know that they are neither one. They are neither parallel nor perpendicular. I don't need more information. I've got enough information. They are reciprocals, but they're not opposites, so they are not parallel, they are not perpendicular. Okay, let's look at number 3. Looks like I'm going to need to work on both of these equations. I have 4x is equal to 3y plus 2, and I have negative 20x plus 15y is equal to 2. All right, the first one. I need y by itself. And I kind of like to have my y on the left, so I'm just going to turn this around. 3y plus 2 is equal to 4x. I can just flip the equation over. I'm going to subtract 2, and I have 3y is equal to 4x minus 2. Divide by 3, divide everything by 3, and y is equal to 4/3 x minus 2/3. Okay, there's the slope of my first line. See what's happening with the second line. I'm going to add 20x. Now remember, my goal is to get y by itself. So I have 15y is equal to 20x plus 2. Divide by 15. And y is equal to, now I have 20 over 15. X plus 2/15. Now 20 over 15 can be reduced. 5 is a common factor. 5 goes into the top 4 times. 5 goes into the bottom 3 times. This is my slope of my second line. These are the same. That means that the two lines are parallel. But it took me a little bit of work to get them both in the position where I could make that determination. Let's look at our last one. I think this is our last one. Yeah. I have 3 plus 3x is equal to 4y. And I have 4x plus 3y is equal to 9. Let's get them both solved for y. I'm going to turn this equation around. 4y is equal to 3x plus 3. I did a good bit of changing there. First, I swapped the left and right sides, and then I used my commutative property to change positions on those. Now I'm going to divide everything by 4, and y is equal to 3/4 x plus 3/4. There's the slope of my first line. Next one, I'm going to subtract 4x. So I have 3y is equal to negative 4x plus 9. Divide by 3. That means divide everything by 3. I get y is equal to negative 4/3 x plus 3. Compare. Okay. These two slopes are opposite in sign. This one's positive, this one's negative. This one's 3 over 4, this one's 4 over 3. So they are both opposite and reciprocal. That means these are perpendicular. Two characteristics, opposite and reciprocal, in order to be perpendicular. In our next lesson, we're finally going to talk about this other number and see what it can do for us.